said there's gonna be a movie night for that, right? Documentary.
But that doesn't.
Yep. We'll
Avoid.
Please don't post. Put in a request to not post it on Tuesday, please. I want to see it this time.
well, we'll have to see.
Well, yeah. I mean, of course, if it was a better day, but I'm just saying.
Yeah, typically, if I'm gonna run it, it's got to be Monday or Tuesday.
Yeah,
Then I prefer Monday, personally.
So we'll.
Anybody, but if it's more beneficial for more people.
Yeah, I get it.
Monday,
But you could also watch that movie yourself by just downloading the app.
What app?
I'll post the thing for the app. It's the Aurora WDC. I think it's like called the G2 app. Shut up! So is he Stacy? Are you in his group?
I'm in his group, yeah.
I was told to mention Stacy in my lecture.
That's big with Noah.
That's a Noah thing?
Yeah, I think it's
That's big with Noah? What does that even mean?
I'm tired.
Clancy, you're late.
I told you my memory was good.
What?
On Slack.
What happened?
They posted at midnight last night. We finally got the solution.
How long did you spend on it?
8 hours.
That's
8
about-
hours? Am I going to be able to solve this in class?
That's about what we spent on
Probably
it too.
5 minutes.
I think we pretty much did the exact same thing you guys did. Came into the business store and we just sat with whiteboards. And even then, like, if we wouldn't have worked in a group, I don't think we would have been able to do it. It was so. We were losing our minds with those pointers.
Everybody was saying it was too easy.
Yeah, exactly. We spent so long on it because we were trying to find a way to make it harder. Like,
Exactly. We
We
were
had like
we were too
5
stupid
people,
to understand this.
5 upper classmen who's been through this class helped us and they all failed.
no way.
Oh, give me names.
I saw Jack was there.
Yeah, I don't know how to snatch.
Jack started showing us a way to do it. And
Jack definitely could do it.
Well, yeah, but I think he just didn't have enough time. He started going with like a solution, and then he was like, "Yeah, this actually isn't gonna work. Sorry for wasting your time."
You just didn't have enough time.
Yeah.
What's this?
You didn't fail.
We didn't fail. We just didn't have enough time. That's what that was.
No, he's saying Jack didn't have enough time,
Yeah.
right?
You didn't fail.
All right, so who else was trying to help you?
I mean, he was the main one. We had Eric, I think, Poole.
Oh, man, he should definitely be able to do it too.
He was more focused on his assignment for.
All right, so didn't get full attention. What else? Who else?
Blaine
popped in
technically,
for a
but
little
again,
bit,
he was
but,
more
like-
focused on the assignment.
Yeah, Blaine could definitely do it.
Again, he was more focused on the art.
So you've got the 3 best choices so far.
Yeah, but the art. but
Okay,
they
who's
all
next one?
focused on their homework.
Huh?
The internet.
The
All right, the internet. All right, that's going to be hit and miss.
Yeah,
He was with
I know, right?
Jack, but she was more of an observer.
Yeah, see, V could definitely do it, but it would take her time. V's not a quick worker. She's smart and she's good at doing it. It just takes her a long time to process through things. All right, well, let's see if I can figure it out.
2 minutes.
Well, I gotta do it at your guys' speed so I can draw pictures.
I was about to say, you can do it.
And I promise I have not thought about it yet. So, and I literally woke up like 20 minutes ago.
You're in your. I saw you walk. You're in your couch. That was really good.
Wait a second.
All right. So, first question is what's the. We're sorting a linked list, right?
Yes.
All right, and our linked list is currently a. Shut up! So, our list is currently a singly linked list, right? All right, so we're going to solve this with a singly linked list. I think you'll find that when we add a doubly linked list, when we start keeping track of tail and previous nodes, this becomes a little bit more convenient, but doesn't really matter. We can make it work regardless. Okay, so let me give ourselves a little sample list here that actually has some stuff in it. And we'll artificially put it out of order.
This picture isn't really what the finished products is doing. It's just showing them.
Well, it'll be something. We'll have to see. All right, so the idea here is that we have a linked list that is not currently sorted. Now, we don't necessarily know that it's not currently sorted because the only list that is sorted by definition is a one list, right? But we can say, hey, I want to make sure my list is sorted, so we can call sort on it, and it will sort if needed. As human beings, we can look at this and say, okay, this is definitely not in order. I'd like this to say 1, 2, 5. Okay, great. So we're going to apply an insertion sort to this, a modified insertion sort. It's the insertion sort I like to use. So what we need to do is, if we're just going to kind of go through the exercise here, we need to start at bucket 1, and we need to compare this guy to whoever's at bucket 0. We say, should a 2 come before a 5? It should. So then what do we need to do? We need to make this guy and this guy switch places. So we need to perform some surgery. All right? All right. So let's start off our function with getting ourselves positioned at the beginning. We'll go in little pieces here. All right. So we're going to add a function. Oh, we already did. We added a function to our linked list called sort. And now we're going to start implementing sort. All right, so the very first thing we want to do is we want to position ourselves at bucket 1 of the of our linked list. All right. Now, one thing we might find handy for this function is to have the ability to run up to a particular index. All right, because we already have a function. Don't we have a function called like run to end or something like that? Yeah, run to end. Why don't we have a thing called node pointer run to index that takes an int index as a parameter. And this will be a nice convenience function where if I need to get to bucket 1, it'll take me to bucket 1. If I need to get to bucket 5, it'll take me to bucket 5, so on and so forth. All right, so we'll go ahead and I'll just write that here towards the end.
Can we turn the TV on?
It's the TV's not on?
Both of them aren't.
Oh.
The one in the back too is not on.
Let's see. Is there a power button? Oh wait, actually, hold on. Maybe I have the remote up here. They're supposed to come on their own. Is there a power button on them? I don't seem to have a remote. I might be able to. Did that do it?
Hold on. I think it's turning on.
Did you find a button over there?
So there's green screen. It's on this side right. It's on this side right here. It's like right.
Yeah, he's got it. But the question is do you have my screen up on yours? But it's not up on yours yet.
Did you take the monitor from the other room over there?
It's okay, you don't have to.
You sure? All right. I'm guessing it's because this was already on this morning. It probably needs the cycle, like I go from off to on to actually get the thing going. All right, so for now on, I'll remember to, if it's already on, to turn it off. All right, so run to index is just going to go through some number of times. So we'll start a node pointer, cur node, and we'll start this off at this dot head. Now, we can again assume that index is a legal bucket. We're not doing error checking at this point. We're mostly doing kind of the type of surgery you pay discount for in Guatemala or something like that. So we have our node pointer, cur node, this head. Then we're going to have a for loop for int I is equal to 0, I is less than index, I plus plus, and we'll say cur node is equal to cur node get next node. So that'll run them down the list, and then we'll return cur node. All right, so this function now, if I say run to index 3, he will return for me a pointer to index 3 in my list. Make sense? Go ahead.
Do you only go less than index because it gets the next one after? How can you go?
Let's say I asked for bucket 0. I don't want this loop to go through at all, do I? So I'm already at bucket 0. If I say bucket 1 is 0 less than 1, it is, so it'll go through one time, taking me to bucket 1. Yep. All right.
Could you just copy the other function that we made before?
Didn't I say run to end?
No, like get at index. Like returns at end, you could just change it to like a node pointer. And
Yeah, done roughly the same thing. Sure. Yeah, but this is just a quick one-off function. So one of the things you want to get from this is the idea is that what did my mind immediately start thinking when I went to solve this problem? What helper functions can I create that might help me solve this problem in a more convenient way? Right? So I decided, you know what? If I ran into Home Depot and this dude was on sale, it might be handy to be able to quickly just get a pointer to a particular index in my list. Right? Keeping in mind that we're already dealing with time inefficiency with linked lists. We're not working with linked lists for speed. We're working with linked lists for memory efficiency. Computers are really fast. We're not going to notice. Okay? So that'll be our run to index. So we want to go ahead and get ourselves positioned at bucket 1. So we're going to say node pointer curpos is equal to this run to index 1. Now, for sort, we only want to do any of this stuff if we have a list bigger than 1, right? So if this, did I make that private? It is, but I'm inside linked list, that's fine. So if this count is greater than 1, then we'll do all this junk. Because if it's not greater than 1, what does it mean? My list is already sorted. It's either empty, which is, I guess, sorted, or it's a 1 list, which is definitely sorted, right? So I'm only going to do any sort of magical stuff here if my list is not sorted. And these are square brackets. Okay. So if I have a list that might need sorting, I'll go ahead and run myself to index 1. And then remember, we've also historically had a pointer called the follower. And we'll start this guy off as the same thing as curpos. Okay? Because curpos is going to keep track of where is our starting point each time through our loop. Where the follower, this guy will change as we follow the thing as it bubbles towards the front of the list. All right? So let's go ahead and add these to our picture. So we have, what do I call this, curpos. So we have curpos, and then we have the follower. Okay? So we start off at position 1. Remember, we're, in fact, let's just use the red things here. This is bucket 0. This is bucket 1. This is bucket 2. So that's our index of our linked list that we're kind of matching up to how arrays work, right? Okay. So we started off at bucket 1, and we want to compare ourselves to the guy right before us. All right. Now, since we are not dealing with physical indexes, it might help us to also keep track that I'm currently at bucket 1. All right. So I'm going to add another variable here. So we're going to actually call this guy cur node at. I'm going to name these guys a little bit better. Let's say cur node at. Yeah, but that's not, this is really cur start. Cur node start. The follower, that's a perfect name. We don't want to change that. And then we'll say this guy's going to be just an int. Cur pos will start off at 1. And we'll position ourselves at cur pos. So we're going to use cur pos to keep track of the numeric location of where we are in the list. Okay? Because that's going to be helpful because we're going to have memory addresses which point to these guys. We don't necessarily know that this memory address is bucket 1 relative to this memory address. So we're going to want to keep track of that, those array pieces of metadata, let's say. All right, so I know I'm going to start at position 1. Here's my pointer to position 1. I know I might be changing this other pointer called the follower. So I'm going to make him start at the current position of node to start. All right. So now that's my setup. So I have everything pointing to the correct place. I'll go ahead and steal a variable here. So what do I call this guy? Cur pos. So am I going to be able to work with cur pos here? Cur pos is equal to 1 right now. All right. And this is my cur start pos, or whatever I called it, cur node start. All right. So now I'm going to ask the question, am I at the beginning of the list? No. How do I know I'm not at the beginning of the list? Because I'm at position greater than 0. So if cur pos, actually what I'm going to do is we're going to keep track of 2 of these. Cur pos is going to govern this variable. And I'll separate these. Then we're going to have a int cur follower pos is going to also start there at the beginning, but he'll change as we move. Because I want this guy to remember where I'm going to be starting my next iteration from. Where I want this guy to follow my value towards the beginning. All right, so this is the index of where this pointer is currently pointing. So if cur follower pos, this guy, is greater than 0, what does that say? That says I have somebody before me to compare myself to. Okay. And something else is true. Now I'm actually going to, well, we'll say what the other thing is true. So cur follower pos is greater than 0, and the guy before me's payload is less than me, or I'm sorry, is if I'm less than him, which means I should switch places, right? So I'm going to actually write this as a nested if, because I'm only going to go ahead and get that guy before me if I have a guy before me. I don't want to start hunting for pointers at bucket -1. All right, so I'll give myself a little temporary variable here. Node pointer temp. So if cur follower pos is greater than 0, if that's a true statement, I'll go ahead and set temp equal to this get index, what did I say, run to index? Run to index of cur follower pos -1. That will get me the node before me. Correct? All right. So if there is a guy before me, go ahead and get a pointer to the guy before me. Then I'll ask the question, if me, which is currently the follower, if the follower get payload is less than temp get payload. So the question we're asking here is, should we swap? All right. So if the current position I'm in, the follower's payload, is less than the guy before me's payload, which I'm only going to check if there is a guy before me. If that's true, I need to swap. So now we need to understand how does swapping work. Notice I haven't even put this in a loop yet. I'm just doing the single move of if we swap, how does swapping work? Okay? So now I'm in this position here where I have a couple other variables. So we have, what did I call this guy? I called him Kerpaz. So he's one. Okay, I already have him. And then for follower, I have Ker follower pause. And he starts off at 1, but he might change. We're only going to increment this guy as we go through, but we'll come back to him in a second. All right, so we have Ker follower pause, and then we have this other pointer that we're going to use called temp. And it doesn't matter where I stick them here. We'll move them up here. So right now, temp is equal to, it's a pointer to the node before Ker follower pause. So it's pointing to the node at bucket 0. If Ker follower pause is greater than 0, which it currently is, what do I do with it? I go, well, what do? I set temp equal to, temp is a node pointer, I set equal to the node right before Ker pause. So that would be Ker follower pause, I'm sorry, did I say Ker follower pause there? Yeah, Ker follower pause -1. Ker follower pause -1 would be 0, so I run to bucket 0 and temp points to that guy. Then I'm asking the question, does the payload at the follower points here, is he less than the payload at temp? This guy's payload. That's the question I'm asking. If the follower's payload is less than temp's payload. If it is, which in this case it is, 2 is, these are the indexes, 0, 1, 2. So 2 is the payload. Is 2 less than 5? It is, so I need to do a swap, i.e. surgery. All right, so now we need to decide, how do I make this picture look like this guy comes before this guy? That makes sense? I already have a pointer to the previous guy, so I won't lose him, right? Now, well, let's kind of go down the path here. We'll see what extra pointer we're going to need. All right. I ultimately want this guy's next pointer to point to the same thing this guy points to. I'm sorry, I want this guy's next pointer to point to this guy. He's going to come after him, right? But I can't do that. If I go ahead and hook that up right away, I've lost track of this guy right here. Okay, can't do that first. So I'm ultimately going to have this guy's next pointer point to my current guy's next pointer. I still have access to this guy through the follower. I still have access to this guy through temp, as well as we can see head. But it's either going to be head or the guy that comes before him. All right, so I want temp to point to the same place that the follower points to. So temp set next node to the follower get next node. Temp set next node to the follower, this is the follower, get next node. So now both of these guys point to the same place. Then I want to say the follower set next node to temp. Not temp's next node, to temp itself. I want the follower to point to the guy that used to be before him. Make sense? So now my order of my list, well, almost my order of my list, is 2, 5, 1. With one exception. I need to have whoever used to point to this guy point to the follower. Right? So if this guy is at position 0, if the follower -1, if cur follower pause -1 is 0, then I need to update head to point to this guy. If cur follower pause, we could ask the question if it's equal to 1 or if it -1 is equal to 0. So if cur follower pause is currently 1, that means the guy we're swapping with is bucket 0. Then we need to say this head is equal to cur, what did I just call it? The follower. All right, so by this picture, what did I just do? I set head now to point to here. So head points to here, this guy points to here, this guy points to here. Make sense? But that's only if the guy before me was bucket 0. If he wasn't bucket 0, there's actually a guy before him that I need to now make point to me. Okay, so here we can, well, I'll just write the code real quick. Here head points off to the front of the list somewhere. All right, so the front of the list is not this guy, it's something way over here. So that means there's actually another node before this guy. So else the guy before me is not the head of the list. That's what this means. And if I want to put a comment in here, the guy before me was the head of the list. So update head. So update his next node. So I need to go ahead and get the guy that was before me. Now, we have a couple of things here. We can cheat a little bit and ask the question, am I going to need this variable temp again right now? Or has he already served his purpose? He has served his purpose in this particular run through swap. I already have somebody else that points to where he points to. I've already done the hookups. So I can actually hijack this variable and use it again to quickly go ahead and get the guy that is cur follow pause -2. That is the guy behind this guy. Or I can create another variable to hold it. Doesn't really matter. But I'm going to hijack them. So I'm going to say temp is equal to this, what is it, run to index. And the index I'm going to run to is cur follower pause -2. That math only works if the guy that was right before me was not the front of the list, right? So I'm only in this else if I'm beyond bucket 1. All right, so I'll go ahead and get a pointer to the node that is 2 behind me, and then I'll set that guy's next node to me. So temp set next node to, so we want that guy's next node to point to our the follower. That make sense? Okay. So will that give us a successful swap? In our example here, it happened to look like this. So that's a successful swap if we needed to swap. Okay. So we're only in this if statement if we should swap. If we shouldn't swap, we move on to the next thing in our list. So we can go ahead and throw an else in here for now. So we'll say else move to the next start pause, just to remind us, okay? After we've done a swap, what happens? The follower follows, right? So we'll say cur follower pause minus minus. Which then would mean that our cur follower, or the follower, sorry, probably should have named him cur follower since I keep calling him cur follower. So since the follower now has, well, since cur follower pause is now a new number, the follower needs to be a new position. We're restarting our search here, right? So we'll go ahead and put that line of code here. I have a feeling we're going to be moving it. All right, so we're going to go ahead and say, the follower is equal to this run to index cur follower pause. Make sense? All right, so if we should swap, go ahead and do our swap, and then the follower follows. The follower follows this guy. You're about to ask the question. Go ahead.
Well, it's probably different. But
Okay, go ahead.
Why do you decrement the current position?
I decremented cur follower position, not the current position. Current position always keeps track of where will I start next time. Current follower position is the guy that the follower currently points to is now in a new position in the list, isn't he? He's no longer at bucket 1. He just became the new bucket 0. So that's why he's there. But let me ask you a question. Does the follower need to change? His relative position in the list does. But does this pointer need to change, or does he still point to the same guy? This guy has now bubbled up the list, right? He's now at position 0 in our list. He's, at the very least, in any list, he would be at wherever he was minus 1. My pointer still points to that node. I don't need to, I automatically follow him, don't I? I didn't lose track of this guy. His memory address didn't change. Just his relative position in my list altered. So I actually will follow by default. All I'm keeping track of here is where is my follower relative to the beginning of the list. He just changed. He was swapped with the guy before him, so now his position is one smaller than it used to be. That make sense? All right. So that's something that is, I guess, a little different than the array version of this, although the array version of this, we're always just using numbers. But when you draw the picture here, we see that even though this guy has changed relative position in my list, he's now at bucket 0 instead of bucket 1, the follower pointer stays with him. Because this just holds his memory address. And I didn't move him in memory. I just rehooked up who he knows about. Make sense? All right, so I don't need to adjust the follower, but I do want to keep track of the follower's pause. That make sense? All right. So this whole logic here says if cur follower pause is greater than 0. This says only if, only do stuff if I am not at the front of the list. If I'm at the front of the list, I've gone as high as I can go. Correct? All right. So if cur follower pause is greater than 0, then I'm going to potentially do all this stuff. Where I'll either swap and the follower follows, or I'll move on to my new beginning place. And my new beginning place will be what? It'll be cur pause. Well, it'll be the position following cur pause. So cur pause plus plus. All right. I'm going to change this just a little bit. I want to keep doing this potentially while cur follower pause is greater than 0. I might keep swapping for as long as cur follower pause is greater than 0. Correct? Now, if I'm in this else, I am done swapping this time. Hee hee hee. LOL. Did I spell it right? I don't know. At some point you'll have to fill me in on what that is. It's apparently some inside joke from their study group. Yeah, I don't know, but it's a Noah thing I've been told.
That's my mom's name.
Oh, is it?
Yep.
Is that the inside joke?
Yep.
Why do they show?
How is that even like a joke?
They're the ones that brought it up.
Or is that an outside of class explanation?
They're the ones that-
All right.
they're the ones that brought it up.
After class, you can fill me in on the dirt. Right now, I am innocently placing a human being's name in my comments. All right. So, I'm done swapping this time around, right? I've moved the follower as far up my list as I can. So I need to move to my next start pause. That is to say, I need to get out of this loop. Does that make sense? How do I get out of a loop? Go ahead. Return does what? Yeah, return immediately ends a method. So if I return here, I'm cutting my sword a little short, right?
Basically, is it something like break?
Well, it's exactly break. Yeah, it's exactly break. So break will get me out of the most local loop. So I'll say, get me out of this loop. So that will dump me outside of this while loop. Go ahead.
So break is the command that gets you out of a while loop.
Any loop.
Any loop. So any for while loop, it just break just flat out gets you out of it.
Jumps you out of it.
And so it puts you right back in.
Well, put you past it.
Oh, okay, I see. so you can do, and then basically.
Break takes you. Take me to the line following this loop. And this isn't a new concept. We've seen break in Python and we've seen break in Java, and yeah, so this isn't.
Yeah, I guess
Yep.
refresher on that.
Right, yeah. All right.
Makes sense.
I'll put a little comment here. This guy right here is the end of our while. So that means this is where I go after break. Correct? Now, let me ask you. Let's start with this. Does this logic seem pretty reasonable for taking a single guy on a journey as far towards the beginning of the list as possible until I've swapped him, until he shouldn't be swapped, or we've reached the beginning of the list? Does this logic look like it does this? Okay. How often do I want to do this? What's the, oh, go ahead. Huh? Until what? Okay. How many times? I won't know if it's actually sorted, except I need to trust my algorithm. But if I'm starting at cur pause, I'm going to start at bucket 1, move that guy as far as I can. Then I'm going to go to bucket 2, move that guy as far as I can. I'm going to go to bucket 3, move that guy as far as I can. How many times do I keep doing that until I get to bucket what? Count -1 would be the last legal bucket. So the last guy I'm going to try to bubble to the front will be position count -1. So I'm going to do this whole thing. I might be moving some stuff around here in a second. But I'm going to say for int I, actually, why don't we say int curpause equals 1. Keep going as long as curpause is less than, this is count, curpause plus plus. And I'll take all of this stuff. And put it in there. Well, that's so handy that it, by the way, if you just highlight stuff and hit tab, it'll indent it as a group. All right, so this is the number of times I'm going to try to bubble stuff towards the front. Each time through, I'm going to give myself these variables. So what do I want to do? I want to set cur node start equal to the beginning guy. You're going to actually see we don't even need that guy here in a second. We never use him, right? We kept track of where I was, but I never actually needed, I did use him relative to the follower, but I could have actually just set follower equal to that guy. Okay, so we can actually say the follower is equal to that guy. I don't need this line then. And cur follower pause will be equal to cur pause. As cur pause changes, starts at 1, then it goes to 2, then it goes to 3, all the way up to count -1, I'll set cur follower pause, I'll reset cur follower pause to wherever the cur pause starting point is. Then I'll set the follower to that position, to a pointer to that position. So I don't need that variable anymore. I will need cur follower pause. So I'll define him up here. I'll use him in here. I'll also need the follower. I'll define him up here. I'll use him in here. So, as long as my list is greater than a 1 list, give myself a couple of variables, cur follower pause and the follower. I'm also going to need this variable called temp that I use for my swapping. I also use it, I hijack it for an extra thing later on when I need to get to the guy before the guy. Okay? So these are 3 variables that I'm going to use. So we'll put a little comment here. Used for swapping as well as an extra little thing. Whatever. Okay? Then I'm going to go through my entire linked list from bucket 1 to the end. Each time through, I will reset cur follower pause to my new version of cur pause. The first time cur pause is 1, then cur pause is 2, then cur pause is 3, yada, yada, yada. Then I'll give myself the pointer to that node. That's the follower. That's the guy we are potentially bubbling towards the front. Make sense? All right. So we're only going to do this stuff if I'm not at the front of the list. Because once cur follower pause is at bucket 0, I have nothing before me to compare myself to. I'm as far as I can go. Make sense? So while this remains to be true, I'm going to go ahead and get the guy right before me. Put a little comment there. Get the guy before me. All right. Then I'm able to ask the question, am I smaller than the guy before me? Should there be a swap? Okay. If the answer is yes, we do our swap logic, right? If cur follower pause was 1, this means the guy before me was the head of the list. If that's true, I'll make the head pointer point to me. Otherwise, he wasn't the head of the list. I'll go ahead and borrow temp and get him to the guy 2 before me. And update his next node to me. Bubbling me up towards the beginning of the list. Make sense? Now, if any of this stuff occurs, what happens? The follower follows. Remember, we're doing this as long as cur follower pause is greater than 0. So at this point, I know that we are still going to be greater than 0 because if I did my swap, either the guy before me was head, or at the very least, I know I wasn't head yet. So cur follower, if I was at bucket 1, I just became bucket 0. The next time through this loop, is bucket 0 greater than bucket 0? It's not. So I just moved myself to the beginning of the list. Now I know I'm done. I'll naturally end this while loop, right? I've moved myself all the way to the beginning of the list. So this is what happens if I should do a swap. If I shouldn't do a swap, I want to unnaturally get out of this loop. I've gone as far as I can, and I have not made it to the front of the list. So I break out of this while loop. That is, take me to the line following this. I'll just throw the while loop in here. All right, so that takes me right here. This is the end of my for loop. My for loops, these are counting type problems where we know how many times we're going to go through. I still want to keep cooking through that, right? So if I've broken out of my while loop, I won't try to swap anymore at this current iteration of the follower. Instead, I'll zip back up, increment cur pause, reset cur follower pause, reset my pointer to the guy I'm going to try to move towards the front. Make sense? When this for loop exhausts, I've gone through every element in my loop, every element in my list, bubbling him towards the front as far as he can go. List is now sorted. I don't return anything because I've just rearranged things in memory, right? Head still points to the front of my list. It's potentially a new memory address. The front of my list may have changed, but my nodes did not change locations. How they are relatively hooked up to each other may have changed. All right, so my list is now sorted, and my sort method can naturally end, or will naturally end. We'll always go through this number of times. We just might not necessarily go through this loop that many times, depending on how much swapping we need to do. All right. Now, do I have to adjust count at all? Did I remove anything from my list? Nope. I just rearranged things. All right. So, go into driver. We looked at our random number generator last time, so we filled our list with, 20 random numbers? Between 0 and 999? Because anything mod 1,000 will give us 0 to 999. Then we'll go ahead and display our unsorted list. Then we'll sort it. Then we'll give ourselves this little divider thing and hopefully see a sorted version of our list. Let's see. That's not sorted. That guy doesn't look sorted to me, does it?
Did you change your .hpp file when you added the new function?
Maybe.
Did you add the run to index or whatever it was?
I think I did that. I would have gotten a compiler if I didn't. Yeah, there's my run to index in my private things there. Let's follow our logic here. We're doing this some number of times. I am calling sort. Let me just do a cout. Bubbling. Cur pause. And we'll put in cur pause there. Just make sure that loop is going through, because otherwise our count could be off. Yeah, it is what you're saying. I don't have a GC blah blah, do I? It's complaining about my run to index. Linked list, HPP, node pointer run to index, int index. Well, then I'll have a bunch of GCH files. I shouldn't have to do that. Where's my run to index? Yeah, this is the guy he's complaining about. Yeah, just compiling the CPP file should give me. That is interesting that the error it's giving me is it's giving me the error as if it doesn't know about the linked list GCH. So if I do G++ star.cpp and star.hpp is what you're suggesting? Let me take out my I did name it run to index, didn't I? There's my linked list, HPP. I didn't save my linked list HPP file. Give me a moment.
Sometimes the most basic
Star.gch. All right. So we'll go ahead and save that file. Then we'll come back out here and we should do GPP or G++ star.cpp.
Oh.
And then ./a.out. There we go. All right. So officially, I didn't have syntax errors. I had a save error.
Oh, it's worse.
So, isn't that funny? You can, I can write logical code for an hour that just works. Forget to save. I have misspellings. All of like the normal, like human being able to walk through life with some sort of abilities I just lack. But I can write code all right.
But then when it comes to saving it.
Yeah, it's all the little things, the details.
Yeah, those important stuff.
Actually, I think that Clancy, you're in charge of making sure I save files.
Jeez Louise.
Weren't you in charge of? I thought you were in charge of like all my stupid mistakes.
Yes.
Wasn't that a thing?
It's too many for one person.
Price increase.
It's too many for one.
You have to
All right, go ahead.
So if you have a node pointer called like marker, and you have a while loop, while marker get next node, that while loop will go until marker doesn't have a next node. Like if you say while node get next node, it's gonna keep doing that while loop until it doesn't.
So we have a node pointer called marker, you said. And then you want to have a while loop that says while what?
While marker get next node. And then that's it.
Yeah, that'll keep going.
Until it gets to the end.
Well, this will keep going as long as marker doesn't have a, while marker does have a next node. This keeps looping while marker does have a next node. Because get next node would return something other than 0. But if you don't change marker inside of there somewhere, then that's going to be an infinite loop or a loop that goes through 0 times, one of the two.
Could you decrease the number of elements in it and then put a display after the for loop so we can see what it does each step visually?
Okay. So you want me have fewer elements. So maybe like 3.
Or like do like 5.
Oh, 3 wasn't fewer enough for you?
That was too fewer. Yeah.
Okay, gotcha. All right, so you want me to do 5 elements, and then you want me to display
if you
what?
go in your-
Inside of my sort?
After the while loop, so I click
So before it goes through the next 4?
Yeah.
All right, so why don't we just do it at the beginning of the for loop, and we just won't display the first time. So you would say this display like that. Oh, that's an underscore. Where were you on that one, Clancy?
Come on.
This is garbage, dude.
I know.
All right, so, and then out here in driver, we just won't do our first display because sort actually is going to display right off the bat. And then you probably, why don't we steal this line? We'll do a final display out there, actually, so I can keep that line in there for there. But I'm also going to, let's put it inside of our linked list. After we display each time, just so we can separate the steps, because you want to see how it's manipulating, right? All right. All right, so we'll go up to the beginning here. So there's my unsorted list. So we started at 185. 185 bubbled to the top. Okay. The next one we're going to start at is 549. Did 549 move at all? Nope, because it's not even less than 516. So the next one we're going to start up is 163. This guy here. And he's going to swap up, swap up, swap up. So now we have 163 at the top. Then we're starting at 166. 166 should get up to everything but before 163. So there's that guy there. So we see how the bubbling works. So my for loop started off here and bubbled that guy as far up as he could go. Then it went to here, bubbled him up as far as he could go. Went to here, so on and so forth. Right? And each time we saw, so the 185 bubbled to the top. The 516, actually 516 wasn't even a part of our check. It was displaced by the 185. So the 549, so bucket 2, we started at bucket 1, which is 185. The 549 was bucket 3, or bucket 2, I'm sorry. So 549 did not come before 516, so he did not move. We checked him. He had a guy before him, but he did not swap. So we moved to our, so we broke out of our loop, our while loop, moved to our next value in our for loop, which is the 163. 163 compared himself to 549, swapped. Compared himself to 516, swapped. Compared himself to 185, failed, broke out of the while loop. So the, I'm sorry, he didn't fail yet. He did beat the 185, broke. So we naturally ended the while loop. Then we get down to the 166. The 166 compared himself to 149. He won, we swapped. 516, swapped. 185, swapped. 163, he does not swap with him. We unnaturally break out of the while loop. Then we hit the end of the for loop. Hence the double. Because we had two different print ones. Right? And this is my final display of the thing in order. That make sense? All right. Questions about that?
I hate that you can do this. I hate that you can do this.
You know how many times we got, how many times we had memory?
We had that discussion last night too, didn't we?
Yeah.
And I don't even, I'm pretty tired. I don't even feel like that was savant mode. So I think the assignment might have been too easy. Killing me, Brocker. I'm supposed to be better at it than you. I got the pink belt.
I'm just.
This is the Grand Master belt, right? I'm just an orange belt.
Yeah, I mean,
Our finish, we're like, we want someone else to
So
suffer
hot
like
pink
we did
belts
when
are
we did this
maybe-
assignment because we worked
Tell
on
me
it.
that even as a hot paint belt, you should even master the art of saving.
Well, I suffered. I had to go slow.
No, I'm not.
Right.
I'm not about the other guys. I'm like, if they get it right away, we are gonna be so bad.
Oh, I mean other students in
Yeah,
class.
We're like, if the other students get it right away, we're gonna be.
Okay, so as students, what you want to see is if you spend 6 hours on assignment, you want other
We wanna
students to
feel like
spend
we were like
in the
six
group,
years
or
young.
even better. You want them to spend 12 hours,
No.
at least 6.
I just want them to feel like that was a challenge, like we had a challenge, like we didn't just somehow like have this completely like just stumped us for no reason, I guess.
Okay, well, so out of how long did you spend on the homework?
Probably like 7 hours.
7 hours.
We,
Probably.
you started working on it, looking at it, and then I went to the gym. We came back another way, and then
We
did.
did.
We did
So
it.
for a while, you spent 6-7 hours,
Pretty much from the time we got out of class until midnight.
but you finally got it working.
Yes.
We were about to throw in the towel and just work.
And then at 1 a.m. just
Why would you quit?
Well, believe me, we didn't want to, but we're.
I wouldn't have quit. I
My
would've quit
body,
for the day.
I was like so mentally tired that I was like,
You went to the gym in the middle of your homework.
no, it was right after class.
Priorities.
I know.
You sit down and you code until it's done. You don't eat. You don't sleep. How long did you spend on it?
Like 2 or 3 hours.
Did you get it working? See, doesn't that make you feel like he quit? He's a quitter.
Were you with the group?
For like the end of it, and I just kind of like tried to do it on my own, and then it didn't work. And I was like trying to do it right before class, and I had Jack look at it, and he was just like, "Yeah, I don't know, I would just quit."
Jack told you to quit?
Well, it was like.
Man, he's not gonna-
It was like 9:45, so like.
Well, like, well, that's because that's so late. Oh, 9:45 today. Oh. I get it. You got 10 minutes before class starts. How long did you spend on it?
How long did I spend? I spent, well, technically I spent like 3 hours with them. I spent an extra 2-ish hours on it later. Started looking at it, and then later I had to do another assignment.
Did you get it working?
No, they eventually got it working.
How long did you, this is the
8
group?
hours.
How long did you guys spend? 8?
Right?
I mean, after you guys finish this.
After you ditch this.
I'm sorry. I'm sorry.
Now, the only assignments that matter are my assignments.
And tell that to Dr. Law.
I can.
Okay.
I'm sure he'll disagree. But
I'm sure.
How long did you say?
No, I think there'd be a problem.
What is it? So my first iteration of this, my first version, it would go through my main up until the sort method, and it would just throw up a cursor. So it would display the unsorted list, and then just put a cursor, but there wouldn't be any compiler errors or runtime errors. So what is that?
It sounds like an infinite loop.
I just like kind of changed things and ran it again, but it's still not. It goes through the whole main method now, but it's just not sorted. So,
Oh, so yours doesn't work either. How long did you spend on it?
3 hours.
We seen a pattern?
The more time you spend, the more.
We had a couple of 3-hour people here, and they got nothing.
Well, I feel like
Hello?
it's structurally sound.
Yeah, it probably isn't. How long did you spend, Sarah?
I spent like 5 hours, but I didn't have a chance to start it until late, so I pulled it all and everything, and still didn't get it to work.
Oh, see, that sucks, but it was dedication.
6 or 7 hours.
So, and get it working?
Partially.
Partially?
When we started.
Not too much, but I can work.
So did you do the 3 hours or not even that?
Not even that.
I put in about 7 minutes and then decided
7 minutes.
this isn't happening.
I looked at the prompt and said it wasn't worth it.
Elias, is he still here? Where'd he go? You're hiding?
He's hiding.
Well, you got to beat 9 minutes. Come on, yellow belt. How long did you spend? You didn't even start it, did you? All right.
About 2.5 hours.
And? Did you give up? Patterns, right? Back corner? How long did you spend?
I didn't get it either.
About an hour?
Yeah.
Did you get it working?
Yep. What? There you go. That is, he uses Savant mode, basically.
That's the definition of savant mode.
If you can finish with this assignment, then yeah, Savant.
Now, I also want to call out another embarrassment in class.
Me.
No, Clancy.
Oh,
What?
So he messages me and saying, "Can we do this with arrays because there's a built-in sort function?"
It was about, you didn't say we couldn't on the assignment page. I'm just saying.
So,
I just
no,
wanted
You
to
realize that
No.
I don't care if you learn or not, but the point of you paying all this money for college is to learn.
No.
And wouldn't logic say that if we're spending all this time on linked lists, then the point is probably to do it with linked lists?
No,
You can still use them.
First of all, I
Put
challenged
them in arrays.
Clancy's assessment that said that you couldn't use arrays. I think I remember you distinctively in lecture saying, I think it was something along the lines of you have to do it. I don't know if you said like the hard. I would have to go back to.
I can tell you exactly what I said. I said you can't use the built-in linked list from the standard template library.
Oh, so Clancy linked it.
Well, not really. I mean,
Well, I know he's still trying to cheat.
trying to do it. Well, it's not cheating. It's just an embarrassment. Yeah.
I don't know if my wording was better or yours.
But in the end, you guys did it without and you got it working.
Well, we also use like the add at front or remove index functions that we had already built,
Yeah.
and that worked. That was
Yeah.
actually-
No, and that's legit.
Yeah.
Yeah, because you would also ask me, can we remove stuff from the list? Was it you asked me you can remove stuff from the list and then recreate it, or was it you guys?
Yeah.
Yeah, so they wanted to say, okay, if I need to swap this, I'm just going to remove it from the list and then re-add it to the right position as a brand new memory location. Right?
I mean, that's the first way I went about it, but then.
But then we kind of but then it wasn't. I saw the mistake. I kind of saw the mistake immediately. 'Cause I remember distinctly.
All right. Well, since this homework was so easy,
Oh boy.
in my mind, I'm thinking merge sort.
Word sort.
No, we don't need to do sorts twice. We got the impression of the.
Unsort.
I'm guessing his is pretty good at that. Man, my unsort's great. It unsorts perfectly. All right, so let's see here. Homework. I'll actually make the homework a little easier that we can start transitioning into something else. So we're going to finish up. We're going to call this doubly linked lists. I'm not sure if that's how you spell doubly. Just put a couple extra Y's in it. Now I have a, all right, doubly linked lists. I actually was cool with it before, whatever. So doubly linked lists keep track of both the head and the tail of the list. Update, actually say update your methods to take this into account. This also, each node keeps track of its next node and its previous node. Does that make sense? So now you know where the beginning of the list is, you know where the end of the list is. Each node knows his next guy, he also knows his previous guy. So consider all the times where we've had to say, oh, I need to go back one, right? And then you have to zip up to the guy right before him. Now you can just get to the guy before him using his previous node. Go ahead.
When you say keep track of both the head and the tail of the list, are you saying that for each node? Isn't that something we already had with
Yeah.
head and tail?
Head equals front of the list. Tail equals end of the list. So at all points in times, you know where the list begins. You also can instantly get to the guy at the end.
So the tail is the new thing.
Tail is the new thing, and previous node
Okay.
is the new thing. Does that make sense? So update your definition for linked lists to keep track of the end of the list, and each node should also keep track of the node before it, previous node, and then update your methods to take advantage of this. For instance, add end You'll no longer traverse your list all the way to the end. You can just go to the end. Hook up tail's next node to that guy and make tail point to the new guy. Done. 2 lines of code. Make sense? Okay, so go through and see the advantage of this change. I'll give you my code. Do it for every single method where it might make a difference. All right, including sort. Other questions? Go ahead.
If we're going to the hackathon, can you still do it?
This is the bribe. I'm going to solve this on Tuesday anyways. If you show me evidence that you went to the hackathon, I'll give you full credit for this homework. Submit an image of you at the hackathon, and I'll give you credit for this homework. Because I know it maybe seems daunting. It's not a very difficult assignment. You're going to actually see, but I also want you to get experience from the hackathon, and you don't have to spend double time. You're going to actually see that even though it's tedious going through the other methods, you're going to see those methods actually will become easier. But if you do go to the hackathon, instead of the code, submit a picture of you at the hackathon, which is what, 9 a.m. to 9 p.m. tomorrow here in CS? Or is it in the new building? It's here in CS. 2 days?
I got you there.
2 days,
There
Saturday.
you go. Yeah, yeah.
Oh, it's 9 a.m. to 9 a.m.
Like 9 a.m.
Oh, I'm sorry. Today's Thursday. Yeah, today's Thursday. Thanks.
Yeah, I got
You did your job. Yeah, yeah.
It wasn't Friday.
I know what day it is.
Well, see, that sucks because now I'm here till 10 o'clock at night tonight.
Oh, okay, it is Friday.
All right, so everybody get that? Submit a picture of yourself at the hackathon, and you don't have to do this. But if you don't go to the hackathon, you got to do it. Yeah. Mr. Gonzalez will only be at the hackathon if I end up making it to the hackathon, which I think I'll at least make an appearance for a little bit. I have to find out. We've been doing washing machine shopping. And unfortunately, my wife takes precedence over you, but if I can show up for a little bit, I will. And Mr. Gonzalez would then make an appearance. He might have to travel in a Ziploc bag. I'll have to check with the boss, but yeah, I think the answer will be yes. All right, everybody understand? Deal with the hackathon? Strongly, strongly, strongly encourage you to go.
What would be proper photographic evidence, like just the fact that you were there? Or like, how would you show that?
I don't know, just prove to me you were there.
Like, take a picture of the group?
Sure.
That's what I was saying, like, I feel like the only way I could prove that is.
Yeah, you don't have to overthink it. Just prove to me you were at the hackathon.
Fair enough.
You know, I'm not going to assume you're a liar until you've proven to me to be a liar.
Gotcha.
All right, I'll see everybody on Tuesday, and I'll push this code up.